Welcome back! How did your algorithm work out? If you're anything like me, then you probably found that you try to apply your algorithm that you have come up with very laboriously and it didn't really work. There was one particular case that you forgot, that you didn't take into account, and you weren't able to reach the exit without injecting some additional knowledge in there. Or maybe it worked on one level and then you played it on a different level and it didn't work there. Now, don't worry about this. This is perfectly fine. And this is one of the reasons why we're doing this at a conceptual level, because a large part of programming and computer science is really iterative, as in you design an algorithm, you apply it to a particular problem, and you find that it doesn't work. Or maybe it works in general, but in particular cases it kind of breaks in weird and wonderful ways. I'm sure you've all seen this, right? So you've worked with some piece of software where you then got an out of cheese error or error 325, which you obviously know what it is, and the program crashed and lost all of your work or ate your cat or something along those lines. This is one of the most challenging aspects of programming and computer science in general, thinking about all the different cases that you might need to consider to make the algorithm work correct in every case, and not crash in weird and wonderful ways and then take your work with it or something like that. So this is really an iterative process where you develop your algorithm, you write it down on a piece of paper, you apply it, and you find that there's some case where it doesn't work, and maybe that only appears in level 10 or something like that. So it might not be immediately obvious because, well, if it were, then you would have thought about this before. And then what you do is you adjust your algorithm appropriately, so you add in a special condition for that particular case. Or you'll find that, well, actually I can kind of refactor that into something that is more elegant overall and also takes care of this special case. And then you apply it again and you find that now you can solve level 10, but it breaks at level 11. And you come back to this and iterate on that. Now, that is obviously much easier if you're doing it at a conceptual level like we're doing it here, so pen and paper essentially, rather than writing the code, spending hours and maybe days getting everything right, getting the syntax right, making sure that you have the semicolon there and whatever, and then realizing that, oh, actually it doesn't work. And maybe you even have to go back to the drawing board and you find that there's a fundamental flaw with your algorithm and you really need to change it very significantly to be able to work correctly. Hopefully that didn't happen here, but again, much easier to do this if you're doing this as a kind of pen and paper exercise before you're starting the actual implementation. And this is actually what you should always do when you're doing computer science and when you're developing algorithms, when you're programming, when you're implementing something. Think about how it works first and then try to apply it and see whether it still works as expected or whether some cases come up where it doesn't work, because then when you actually get to implementing it, when you sit down and write the code, you have a much better understanding of what the algorithm should do, what it should take into account, when it might break, what you might have to consider for that, etc., etc. And really a lot of this comes down to what we've already talked about, that we as humans do this intuitively. We don't even think about a lot of things, and we don't even realize that we don't think about a particular thing. It is only when we try to teach a computer how to do it and realize that, oh, this breaks. Well, why does this break? Well, the computer did this thing that was obviously stupid. Okay, I guess I have to find some way of telling it not to do that obviously stupid thing. So this is a lot of what programming and what we're doing here, designing an algorithm, is about. So hopefully that gave you a better understanding of this entire process here. As I said, if you didn't get it right, perfectly fine. Almost nobody does. If you did, congratulations, you're on your way to becoming a really great programmer, but I would certainly have to go through various iterations there where I come up with an algorithm, I apply it, I find that it breaks in some cases, and then I revise it, go back and go through this iterative loop a couple of times. Hopefully that was a fun exercise as well, and again, something you can directly take into the classroom. Might be a bit of a challenge to get your students to just apply an algorithm without thinking about it, because of course a lot of school is about teaching people how to think. So abandoning that and now being the stupid computer can be a bit of a challenge, but it's also very instructive because it can really help you to think about programming and think about computer science in a way that will eventually help you to implement your own programs, to really think about what they do, when they might break, all of the things we have talked about, and eventually become really, really good at this.